Bismillahirrahmanirrahim. With the name of Allah, who is very kind and merciful. Welcome to my Topper Student channel. In this channel, you will find the solution of mathematics and computer science for OE level past paper. Today, we shall discuss question number 6 of paper 3, Pure Mathematics, session May June 2023. In order to search this channel on the YouTube, please use the word My Topper Students. You will find the channel My Topper Student. For online tuition, please contact on this WhatsApp number. In paper 3, Pure Mathematics session by year 2023, the question number 6 says as follows. The equation cot x by 2 equal to 3x has one root in the interval 0 less than x, x less than pi, denoted by alpha. Show that by calculation that alpha lies between 0.5 and 1. Now the solution for the part A, we shall show that the solution lies between 0.5 and 1. The given equation is cot x by 2 equal to 3x. By arranging the equation f of x equal to cot x by 2 minus 3x. As x equal to 0.5 is given, so f of 0.5 equal to, after simplification, we get f of 0.5 equal to 2.1616, which is a positive value greater than 0. Now, when you are doing the calculation, please make sure that you convert your calculator to the radians. Now, at x equal to 1, f of 1 equal to cot x1 by 2 minus 3. After simplification, we get x equal to f of 1 equal to minus 1.169 less than 0. It means that the sign change between 0.5 and 1, so the root lie between 0.5 and 1. For the part B, show that if a sequence of positive value given by the iterative formula xn plus 1 equal to 1 by 3 into xn plus 4 tan inverse 1 over 3 xn converges, it converges to alpha. We shall show that if the above iterative formula converges, then it converges to alpha. Now we shall prove that the above given equation converges to alpha. In the part 1, we have proved that the value of alpha lies between 0.5 and 1. So the given equation is xn plus 1 equal to 1 by 3, xn plus 4 tan inverse 1 over 3 xn. Without substitution, we have x equal to 1 by 3, x plus 4 tan inverse 1 over 3x. After simplification, we get 2x, 4 tan inverse 1 over 3x. Now, when we arrange it, we get tan x by 2 equal to 1 over 3x. After simplification, we get cot x by 2 equal to 3x. So, it's converges to alpha. Because this is the equation given in the part 1, which we have proved that this equation converges to the root between 0.5 and 1. So, the given equation converges to alpha from part A. For part C, xn plus 1 equal to 1 by 3, xn plus 4 tan inverse 1 over 3 xn, equation number 1. From part A equal to 0.5 as given root in part A, b equal to 1. x1 is equal to a plus b over 2. We shall use the formula a plus b over 2 for the first root, which is equal to 7.5. When we get n equal to 1, x2 equal to 1 by 3, x1 plus 4 tan inverse 1 over 3 xn. As x1 is equal to 0.75, by putting the value of x1 in the equation, this one, after simplification, in this equation, after simplification, we shall get x2 equal to 0.8076. Now again, because this is the iterative solution, we take n equal to 2. When we put n equal to 2, we get x3 equal to 1 by 3, x2 plus 4 tan inverse 1 over 3 x2. As we have calculated in the previous step, x2 is equal to 0.8076. When we put this value for the x2, after simplification, we get x equal to 0.791. Now, for n equal to 3, by putting this value, we get x4 equal to 1 by 3, x3 plus 4 tan inverse 1 over 3 x3. Now, as we have calculated, x3 is equal to 0.791. After putting the value of x3, after simplification, we get x4 equal to 0.7954. If we compare the value of two previous value like x3 equal to 0.7911 and x4 equal to 0.7952, first two after decimal first two digits are same. So as the first two decimal digits are repeating, so x equal to 0.79. The answer of this part C. Thank you for watching the solution prepared by senior A level teacher. Wish you good luck for your exam.